All right, so this is a lot of vocabulary for 12.1 and 12.2. So you have, there's your vocabulary that if you need to pause it, go ahead and pause it and write it down. Population sample, that is the difference in your entire group and just the sample that you would take of your population. And of course, remember standard deviation and variance, those are linked. Standard deviation, if you run your statistics on the calculator, standard deviation will be given to you and it will be this little symbol that a lot of my students last year called the hat, and it's the lowercase sigma, and you actually have two of them. So there's sigma, that's the population standard deviation, and then you will also have sample standard deviation. Majority of the time, as far as I remember, you will see sample standard deviation used, but it tends to be, like your entire group is what it refers to. Variance, if you have your standard deviation given to you, if you're asked for variance, take that number and square it. What we are going to be using today is univariate data. It is one list, one variable used to describe a study, and then bivariate is what we had done. It's what we've done a lot of. Anytime you have parabolas, lines, when we had done regression, we had x, y, we created our scatter plots. That was bivariate data. So there is a lot of vocabulary there. Mean, median, and mode, which you have done before, describes pieces of sets of data. Mean is more appropriate when your data has no outliers, there's not a strange number out there. Median, if you have an outlier, you have a group of data and then there's one strange odd number that's just way out there, then median is more appropriate to describe your data. And then when you have a mode, you have many repeated numbers, then mode is most appropriate for your data. So if we look at these lists, then we have one of those measures of central tendencies, which is most appropriate. So this one, these are roughly 20-something numbers. So mean is more appropriate there. Because we have this mode of 5, this list is most appropriately described by mode. This is a pretty good, 20-something is where the numbers are rocking and rolling around, except for we have this 61. So median describes this list. So imagine these are quiz numbers, and all of a sudden I have a 61. Maybe I went back and then I put a grade in there wrong. And then of course mean is right here. We've got 800s. So that is there. This is called sample error. Very simple calculation. 1 over your square root of your sample size. So if you're given the report of how a study goes, they'll give you a percent of how the sample goes and what is the margin of error. So here's how you calculate your margin of error. You add and subtract this to how did your study come out. So here's what that looks like. So you have a survey of people, 2,148 people who were surveyed. 58% said they like football. What was the margin of that sampling error? And so we square root that sample, and that is divided into 1. So it comes out to this decimal. We can round that. And we take this outcome of the survey. They said 58% liked football. So as it's decimal, we subtract and add that sampling error. Here's our answer, and we can round that as well. So our margin of error is between 56% and 60%. So that's a margin of error. So when you hear those approval ratings for like the president, and they might say, oh, he has a 58% approval rating with plus or minus 2 margin of error. That would be where they get their plus or minus 2 margin of error in their approval rating report. If I want to create a box and whisker plot, just so you can understand how we compare mean and things like what are called interquartile range. Where do I get that from? Things like that. What are called one variable statistics. Why is it one variable? Well, because I have just a list of numbers, univariate data. I need to find my median. Medians come from, you have your data in order. So I've got this in order from least to greatest. And so I can identify my minimum and maximum. My median is in the middle. I have two numbers in the middle, so I have to add them up and divide by 2. And here's my median in here, which I don't have written down. It is 37.5 mathematics. Then I have this lower half of the data. So split in half. I have 6 numbers here. I have 3 numbers in the first half of the data. I have 3 numbers in the upper half of the data. The middle number in this lower half is 29. That is called my lower quartile, Q1. My upper half of the data, the middle there is 45. That is my upper quartile. It's called Q3. So those numbers are what will make up your box and whisker plot from middle school. So here is 16. Here is 29. Here is 37.5. And here is 45. And notice this has no whisker because my maximum is also 45, as well as Q3. And when you are creating, if you're creating it by hand, and if you let your calculator create it, which you guys did not see, but your calculator does as well, the number line is scaled for you, and you see the relative size of your box and whisker plot, where most of your data is. So we have all 3 of these numbers are right here within this, as well as the median, right here within this box, whereas all of this data is the box and the whisker, so it's spread out more, whereas this is all clumped right here. So it gives you a good picture of what that data is like. So we have like one number right here. It's all represented right here, and right here on the quartile. So the quartile and your other number, your other piece of data, and your maximum. So it gives you a visual of what is your data doing. And your calculator runs a program and calculates all this. It also gives you standard deviation, which remember you can square to get your variance. And interquartile range, your I, Q, R, is, now if you remember range is the maximum minus the minimum. If you are doing interquartile range, you take your quartiles and subtract them. So I would do 45 minus 29, and I would get 16, and that would be quartile range. It's for one variable statistic.